Sketch reciprocal function. This time we'll sketch reciprocal function of f of x equals to x squared. So let us first sketch x squared itself, and then we will sketch reciprocal of this function. X squared is a parabola with vertex at origin. So let's say this is the first point, and the steps are 1, 3, 5, 7. 1 square is 1, 2 square is 4. You can draw like that also. Well, we'll do steps. So first is the vertex, second is step of 1, then step of 3, 1, 2, 3, so on. And from the symmetry, since it is symmetric about the y-axis, we can plot the other points. And I will draw a dotted line to show the function x squared. So that is the function f of x equals to x squared. And now what we need to do is to sketch reciprocal of this function. Now reciprocal of x squared, let us a g of x, which can be written as 1 over x squared. So that becomes the reciprocal of the given function. Now as you can see, the first thing is, these are few things which we should consider while sketching reciprocal functions. So first one is vertical asymptote, then behavior near vertical asymptote, then we'll get to horizontal asymptote and behavior near horizontal asymptote, that means end behavior. Invariant points are the points which are common between the function and its reciprocal, and then we'll discuss about domain range of the reciprocal function. So let's start with vertical asymptote. So vertical asymptote will be when denominator is 0, right? That means when x squared is 0, so that is at x equals to 0. So that is the vertex itself, and let's draw a dotted line to indicate the vertical asymptote. So that is the vertical asymptote, and I'm writing the equation for vertical asymptote as x equals to 0. Now let us check the behavior near the vertical asymptote. When we say behavior near the vertical asymptote, that means we should take a point which is very close to 0 on the left side and on the right side and check its value. Value of 1 over x squared, right? As you know, value of 1 over x squared will always be positive, correct? So if we are approaching, if x is approaching 0 from negative side, that means from the left side, then also it is going to be positive, since the function is positive. Its reciprocal will be positive, right? Or when you approach 0 from the positive side, that means from this side, the function is positive, therefore its reciprocal will also be positive. So in both cases, the reciprocal will be, that means g of x, we can say g of x will approach positive infinity, right, as shown here upwards. So that is a behavior near the vertical asymptote, right? So we have considered the vertical asymptotes and its behavior. Now let's get to horizontal asymptote. When we say horizontal asymptote, what do we really mean? We really mean what happens to the value of reciprocal function in this case when x approaches negative infinity and when x approaches positive infinity. If the function approaches a value, then we say that the horizontal asymptote exists. In both the cases, we see that the function g of x approaches 0. And it approaches 0 from the positive side also. So that's a kind of behavior, right? So the function approaches 0 kind of like this. That is how the function approaches 0 as we increase the value of x towards minus or plus infinity. For a very, very high value, the function approaches 0 but still remains positive. That is kind of critical to understand. And that is what we call end behavior, right? So we do have a horizontal asymptote. Since the function approach 0, we have a horizontal asymptote, and the equation of horizontal asymptote is y equals to 0. So that is the equation of the horizontal asymptote. So I'm writing here y equals to 0 is our horizontal asymptote, correct? This is vertical asymptote. Now invariant points. Invariant points are the points where the value of the function is 1, since reciprocal of 1 is also 1. So the points here which are invariant are 1 and 1 and minus 1 and 1. So these are the points which are common to both function and its reciprocal. Now with that much of information, we can definitely sketch a very neat graph of this function, right? So we know these are the invariant points. To be more accurate, what we can do is we can take some values here. For example, we can have x equals to half, so it will be 4, correct? So at half it will be 4. So we can take some values. We say what is g of half equals to. So g of half will be equals to 4, right? And we can also take a value, for example, and from the symmetry we can say, well, g of minus half will also be equals to 4, right? So that could help us to give one more point just to maintain the accuracy of the graph. So at half we are expecting a value of 4. 1, 2, 3, 4 kind of here, right? So that is at minus half and plus half. With these points we can join and make our graph. So that goes through the invariant point, right? And then continues, approaches 0. When we say approaches, that means we have to just approach, we don't have to touch the axis, right? That is our reciprocal function for 1 over x squared. As you can see from here, domain of the function is all real numbers except for x equals to 0. That is a vertical asymptote, right? So we can write domain as x belongs to real numbers where x is not equal to 0. And as far as range is concerned, range is y belongs to real numbers where y is greater than 0, right? Since we have a horizontal asymptote, y equals to 0. So that is how we can answer this question or kind of understand how to sketch a reciprocal of a quadratic function which is like x squared, the parent quadratic function. I hope you understand the concept. So let's get back and review what we did. First thing, draw the base function, which is f of x equals to x squared. Now to draw the reciprocal of the function, first thing is find the x-intercepts. X-intercepts will result into vertical asymptote for the reciprocal function. Then consider the behavior of the reciprocal function on left and right side of the vertical asymptote, close to it. You can take a value to check whether you get positive or negative answer. Of course, your value is going to be very high, but we are more bothered about their sign, whether it's positive or negative. Since x squared is always positive, both will be positive. Then consider about the horizontal asymptote, which really means that if x is infinitely large, whether positive or negative, does the value of the function approach a fixed value? In this case, it approaches 0, and therefore horizontal asymptote is y equals to 0. Since x squared is always positive, reciprocal of x squared is going to be positive, so it approaches 0 from above the x-axis. Domain is all real numbers except for x equals 0, and range is greater than 0. So with that, let's move on to more examples. Thank you.